A big part of word problems is using an appropriate and useful definition of our variable. We decide what the variable represents, and then we model an algebraic equation around the problem that's given at hand. Then we use our techniques that we've learned to solve for the variable that we want. The book goes through a lot of step-by-step making and solving these problems. So if you're having issues, I recommend looking through the section materials. For this first part, I'm just going to translate words into equations. I'm not going to solve them. That's typically the hardest part, is translating the words into the equations, and then we can solve. But the second part, I'm going to actually solve a bunch of word problems. So for this first problem, it says the sum of two weights is 167 pounds. We want to model this as a word problem. Well, we have two weights. That's what's important here. And we can actually designate these two weights as variables. We can do this a lot of different ways. We can say X and Y for the first and the second weight. I'm gonna say weight 1 and weight 2. But you can write it however you want. You can say A and B, M and N. Anything really works. And we know that the sum of these two weights is 167 pounds. Well, is typically means the equal sign, so this is 167 pounds. We can't solve this for anything because we don't know what one of the weights are. We'd have to know something else. This is actually an equation with two variables, and you cannot solve a single equation with two variables because you don't have enough information to solve it. Okay, moving on. The weight in kilograms is equal to 0.454 times the weight in pounds. So the weight in kilograms, well, I'm going to use WK for weight in kilograms, and then WP for weight in pounds. Typically, we use variable definitions that relate to the problem. The more it relates to the problem, the easier it's going to see what these variables mean. In this case, we have the weight in kilograms is equal to 0.454 times multiplication the weight in pounds. So there's an equation that's coming from the words. The volume of a cone, and this should be pi, not just p. So it's just going to be the pi symbol. The volume of a cone is 1/3 times pi times the height, which is going to be h, times the square of the radius. We have h times, so the square of the radius, if we have the radius and then we take the square of the radius, that's just the radius squared. The volume equals 1/3 times pi times h times r squared. The cutting time for a lathe operation is equal to the length of the cut. So we can say cutting time, I'm going to say the cutting time is equal to the length of the cut divided by a fraction bar there, divided by the product. So the product means the multiplication of the tool feed rate. I'm going to use F for that. And the revolution rate, I'm going to use R for that, of the workpiece. And these are multiplying because it's the product. The cutting time is equal to the length of the cut divided by the product of the tool feed rate and the revolution rate. All right. The voltage across a simple circuit, is equal to the product, again we have a multiplication, of the resistance, we could say R for resistance, and the current, the product of the resistance of the circuit and the current flowing through the circuit. So we have V equals the product of the resistance and the current. Now in practice, this is actually written as V equals IR. That's the same thing as V equals I times R, where I is the current in amps and R is the resistance. And they use capital letters for those. But you know, if you're just writing down a problem, if you're solving a problem by yourself and you're given this, you could use this. It works just as well. Okay, and now we start solving some of these word problems. The first thing I'm really going to do is I'm looking to see what are my variables. What am I looking for? How can I use the variables, and how can I use what's given to me and relate the variables in some kind of equation? All right. Sometimes these are going to have more than one variable. Sometimes they're only going to have one variable. If we have more than one variable, we have to have more than one equation to solve for it. The amount of variables we have, we need that many equations to solve for a single variable or for all of them. Okay. In this problem, we have two metal casings that weigh a total of 84 pounds. So we know we have two metal casings. I can name them right off the bat as we could say casing 1 and casing 2. So C1 and C2. You could name them X and Y. You can name them A and B. Like I said before, you can name them, you know, a lot of different things. But I'm going to use the words, the letter C to designate casing 1 and casing 2. Now it says the two metal casings weigh a total of 84 pounds. Now I have my variables here, and I can actually use that first equation that says weigh a total of 84 pounds. Well, if they weigh a total of 84 pounds, that means together, right? Together, meaning we add them together, that's going to be the total weight, and that total weight is 84 pounds. So we can't solve this, right? We have two variables and we only have one equation. We must have another equation, and that comes from the rest of the information. One weighs 12 pounds more than the other. Now, which one weighs 12 pounds more than the other? It doesn't actually matter. It could be C1 or C2. It doesn't matter which way you write it out. Sometimes it does. Sometimes the way it's written matters. But in this case, I'm just giving them general variables. So I can just say C1 equals 1 weighs 12 pounds more. This is 12 pounds more than the other. So C1 weighs 12 pounds more than C2. That's the equation for it. I can, like I said before, I can flip C1 and C2. I could say C2 equals C1 plus 12. There's no I haven't specified which one's the heavier one. You can say that, but you have to make sure it goes in the rest of your problem. But I'm just going to leave it ambiguous so that I can do things like this. I can say either way. I'm just going to say the first way here. And now you see C1 and C1. Well, C1 equals C2 plus 12, so I can plug in C2 plus 12 into C1. Plus C2 equals 84. And this is a linear equation with one variable, namely C2, that I can solve. Then I can go backwards and solve for C1 by plugging back in the answer, because we're trying to figure out how much does each one weigh. C2 plus 12. I'm just solving this equation. These parentheses don't actually mean anything, so I can drop them. And now you see I have like terms. C2 plus C2 is 2C2. I'm going to subtract 12. Giving me 2C2 equals 72. And divide by 2 to get C2. So C2 equals 72 divided by 2 is 36. If C2 equals 36, then what does C1 equal? Well, we have C1 equals C2 plus 12. And if C2 equals 36, then C1 equals 36 plus 12, which is 48. And of course, you can check your work. C1 plus C2 must equal 84, right? That's what we were given in the first place. So C1 plus C2 equals 48 plus 36. which equals 6 plus 8 is 14. It's going to be 40 and 44. This gives us 84. Yep, that's what we got there. So we have a 41 or 48 pound casting and a 36 pound casting. Total project costs $1,120,000, and it's for budgeting a roadway. This comes from breakdown of 3 different costs: cost of the pavement, the cost of the base material, and the cost of the sidewalk. And the rule of thumb for this type of project is that the pavement costs twice the amount of base material, and the sidewalk costs 1/4 the amount of the pavement. Using these figures, how much should each item cost? So we know that if we add up the pavement, the base material, and the sidewalk, the amounts for all those, then the total project should equal $1,120,000. So I've given the variables already. Pavement is P, base material is B, and sidewalk is S. Those are the costs associated to making those things. Because we're talking about costs here, we're talking about money. Okay. Now that's kind of the first piece right there. Is now we have a single equation here. We have 3 variables, which means in order for us to solve for any one variable, we need to know 2 more equations, because you need just as many equations as you do variables. Let's look at the rest of the piece of information. The rule of thumb for this type of project is that the pavement costs twice the amount as the base material. So the pavement costs, in other words, the pavement cost equals twice the amount of the base material. So the base material was 200,000, let's say, and the pavement will be twice that. So it'd be 400,000. If it was 500,000, the pavement would be $1 million. In other words, P equals twice B. Now we also know that the sidewalk costs 1/4 the amount of the pavement. So 1/4 P, 1/4 times P there. You could also say this is as P over 4. I'm gonna leave it as 1/4 P, 1/4 times P. I think it's gonna be easier to work with. So if the pavement costs $400,000, then the sidewalk would cost $100,000. It's just 1/4 of whatever that is. I'm just giving you examples to make sure you understand the relationship there. But now you see we have 3 equations, we have 3 variables, we can solve for this. And I'm going to do that by first taking this first equation. Let me do it here with the red. If P equals 2B, and that means each of the red boxes can be replaced with 2B. We still have two variables here. We have B and we have S. We need only one variable to solve for it. And that's going to come from plugging in this thing here. I should have done this the other way first. That's fine. Let me see. Let me do like this. S can be replaced with 1/4 P. But P is once again 2B. So I can replace the red box with 2B. 1/4 times 2B. Now I can solve for B because I have only B variable in the equation. I can actually solve for it here. Really all we're doing is we're just plugging things in for each of the variables to solve for it. Okay, 1/4 times 2. It's 2 over 1. We can reduce by 2 and we get 1/2 B. Now you see we have like terms. 2B plus B is 3B. And now we have fractions to add. We have 3 over 1. I can multiply this by 2 to get common denominators. That gives me 6 over 2b plus 1/2 b. 6 over 2b plus 1/2 b is 6 plus 1 is 7 over 2b. This is going to equal the 120 or $1,120,000. Now to solve for this, all I have to do, I've written this a little weird, so I'm just going to rewrite it down here to make it a little bit clearer to see. 0, 1, 2, 3. All I have to do is get rid of the 7 halves. I'm going to multiply it by 2 first to get rid of the denominator. That gives me 7b equals 224. Now divide by 7. So b equals, get a calculator here, 4 zeros. So b equals $320,000. That's the cost of the base material. I know that because my variable b references the base material. Okay, if b equals 320,000, and that means this b here equals 320,000. So P equals 2 times $320,000, which means P equals $640,000. That's for the pavement material because I know P references the pavement. Finally, S, which is the sidewalk material, is 1/4 P. Well, P is 640,000. 1/4 times that is 16. 160 is $160,000. So those are my amounts. Let me box it in here. And to do that, all I've done is I've made sure I had I used every single piece of information with these top three equations here. I use every single piece of information to get an equation, and I just started plugging things in. And finally, once I had one variable, I was able to solve it, combine everything together, solve it for that, and then go backwards using the stuff I found to find the other pieces of information I needed. You can check your work adding these three things up. 640,000 plus 160,000 plus 320,000 gives me 1,120,000, which is the amount that said the total is budgeted for the roadway. We have a building foundation that has a length of 82 feet and a perimeter of 292. What is the width? In this case, we can actually, let me do black here. We can do a picture. The length is 82 feet. We don't know what the width is, that's what we're trying to find. And the perimeter equals 292. It gives us a hint that the perimeter equals 2 times length, 2 times width. You can see that by just saying, well, the perimeter is the outside edge. So in other words, it's the width times, or width plus the length, plus the width again, plus the length again. So it's going to be the perimeter equals the width plus the length plus the width plus the length again, which is the same thing as 2W plus 2L. So we know the perimeter is 292, and we know that it equals twice the width plus twice the length. Well, the length is 82 feet. Now we have a single variable here in a single equation, so we can solve for the width quite easily. We just need to use the two-step equation solving. First, I'm going to do 2 times 82. It gives me 164. I'm going to subtract 164 first to get the variable term by itself. I'm not sure what that is off the top of my head. Let's do 64, 128. Now I can divide by 2 to get the W by itself. And that gives me 64. That's going to be in feet since the length was in feet. So this is a 82 by 64 foot building foundation. An empty avocado crate weighs 42 kilograms. How many avocados weighing 0.3 kilograms each? That should really be in commas. How many 0.3 kilogram avocados can be added before the total weight of the crate, so that includes the avocados and the empty crate itself, how much can be added before the total weight reaches 15 kilograms? We're just trying to figure out how many can we put in there before we get to a max weight of 15 kilograms. Well, we have avocados. We're asking how many avocados, so I'm going to say A is the number of avocados. And I use A obviously for avocados. How many, so if we use A avocados, the number A, whatever that number might be, then how much does that weigh? Well, that weighs 0.3 times A kilograms, because each avocado weighs 0.3, so in total it's going to be 0.3 times A. Now, of course, to find the total weight, we need to add onto this avocado weight the weight of the actual crate, which is 4.2 kilograms. So this right here represents the total weight of the crate with the avocados in it and the weight of the crate itself. And we want to know, well, when is this thing equal to 15.0 kilograms? So all we have to do is solve for this, and we can find how many avocados needs to be can be put into there to make 15 kilograms. Well, this is a two-step equation. First, let's subtract 4.2. 15 minus 4.2 is 10.8. And now we can divide by 0.3, giving us A equal to, I get 36. So that means we can put 36 avocados into the crate. And if we do that, the total weight of the crate is going to be 15 kilograms because of the 4.2 kilogram added onto it. It's going to equal 15 kilograms total. So that means we can have 36 avocados per crate. Auto mechanic has total receipts of $1861.16 for a certain day. He determines that $12.40 is for labor. The remaining amount between the $1861 and $12.40, those can be like $600, something like that. That $600 is for parts plus 6% sales tax on the parts only, not of course on the labor, because that's not what sales tax is. We need to figure out what is the amount of sales tax that he collected. So in most of these problems, there's multiple ways you can do this. A lot of them you don't even need to make an equation for, but we're trying to make an equation so we get used to doing it so that we can get to harder problems and know how to do it. In this case, I'm going to make an equation it's going to be kind of weird. You don't need to do it this way, but I'm writing it out this way because I think it's more clear to see what's going on. So his total receipts equal $1861.16. That's how much he, I guess, billed the client, I guess? I'm not sure. Or billed clients in general. So we know that this breakdown, the first thing this breaks down into is labor costs plus part costs. The remaining amount is for parts plus the 6% on sales tax on parts only. We have a parts cost plus a sales tax cost. I guess I'll use T for tax. So we have that's what's breaking down this 1861.16. What we want to know is how much sales tax. We want to know what T is. But to find T, we need to know what P is. That's because if it says plus 6% sales tax on the parts, which how that works is that saying that the sales tax equals 6% of the parts cost. So we can plug this thing into here and we can solve for the parts cost. We don't really want to know what the parts cost is. What we want to know is the sales tax, but we need to know what the parts cost is first to find the sales tax. There is a way of solving for just the tax. I think it's a little less clear what we're doing here to do that. So I'm not going to do that here, but there is a way of doing it. Okay, I can combine like terms. We have the p's there that can be combined. P plus 0.06p, that's the same thing as 1p plus 0.06p. In other words, 1.06p. And this is just a two-step equation. Subtract 1240 to get the p term by itself. A little more room here. We get 1.06p equals, it's going to be 62116, 1.06. That gives us p equal to I'm getting 586. So to find what the sales tax is, we can either, subtract, we can subtract 1240 plus 586 from 1861.16, or we can just plug this number right into here. And that will tell us what does t equal. I'm going to do that. So t equals 0.06p, which is 0.06 of 586. 0.06 of 586 gives us 35.16. That's how much sales tax the auto mechanic had for the parts. Newly established carpenter, which is the mail out letters, the families. There's two ways that she can do this. First, either mailing the letters out, directly with first class postage, or obtaining a bulk rate permit and then mailing them each letter out at a cheaper rate. So the problem with the bulk rate permit is that the permit has a cost of $215, whereas mailing the letters out at first class is just a single rate per letter. So the bulk rate is, I'm looking right here, $215, and each piece of bulk rate costs 29 cents. The first class rate is just 47 cents per letter. So it's asking how many pieces would she have to mail in order for the bulk rate to be the cheaper way to go? Because obviously the bulk rate's not cheaper if you're going to be mailing out one letter, right? If you mail out one letter, so we say, I'm going to say M for mail, like one piece of mail. So if I say M equals to 1, then that means the bulk rate cost would be $215 plus one piece of mail times 29 cents. So 29 cents times one piece of mail. Well, that's just going to be 1 times 20.29 is 0.29, and that gives me $215.29. Which is obviously a lot of money to spend for a single piece of mail. And of course, if she did it the first class rate, that's just 47 cents times her one piece of mail, which is 47 cents. So in this case, the first class is cheaper. I can spell here. This is the bulk. If she mailed 2 pieces of mail, then that's going to be $215 plus 29 cents per each mail. So it's going to be 29 cents times 2. That gives us $215 and 58 cents. For first class rate It's just 47 cents for two pieces of mail. So that's going to be 94. So you see that first class is definitely cheaper if you have a smaller amount of mail. So at what point does it shift? Okay, it shifts when the bulk rate equals the first class rate. So if we know when they're equal, we know when, if you have more mail than that equal point, the bulk rate's going to be cheaper. And if you have less, well, the first class then would still be cheaper if you have less than that mail. I've just shown that. So we're looking for when is the mail more than that equal point. So the equal point's the key thing here. How do we find the equal point? Well, let's actually create an expression, or an algebraic expression for each of these things. For the bulk rate, you can actually already see it here. 215 is the standard cost, and that's going to be adding on to the mail cost, which is always going to be 29 cents times how much mail you send out. And how much mail you send out is exactly our variable m. So we have 0.29 times m. That's the cost of each piece of mail, or however much mail you send out at the bulk rate. The first class is likewise, it's 47 cents for each piece of mail that you send out. It's going to be 0.47 times m. Now, when are these equal? Well, just set them equal to each other and solve. So we have two sets of variables. We need to get them on one side of the equation first. To do that, I'm going to subtract 0.29m to the other side. And that gets my variables together. And it's going to be 18 cents, or well, 18.18. And now you see all I have to do is divide by 0.18. That gives me the even point where they're both the same. I'm getting 194.444 repeating. Of course, you cannot send out a 0.44444 of a letter, which means there's actually not a simple breaking point. That means that if you go lower, 1194, first class is still going to be cheaper. If you round up, now you have 1195. This is where the bulk is going to be cheaper. The difference is only going to be a couple cents, but that's the shifting point. So 0 to that, and then that on up to infinity. You can actually test this and see. If we had 1194, the first class rate is 47 times 1194. That's 561.18. If you did the bulk rate at that same amount, it's 29 cents times 1194. And you see we have 561.26. The bulk rate is still, this is the bulk. The bulk rate is still more expensive at this point, but only by what looks like 8 cents. Now, when we go up one, right, if we're going to go up one single letter for both of them to 1195, doing that gives us 561.65. $561.55. Now the bulk rate is cheaper. In this case, the first class was cheaper. Now the bulk rate is cheaper by 10 cents. So that's the breaking point right there. which means if she plans on only spending 500, sending out 500 letters, she should definitely just use first class. If she plans on sending out 2,500 letters, then the bulk rate is going to be cheaper. We have 4 partners in a plumbing business that decided to sell it. And based on their initial investments, we have 4 people receiving different amounts of shares of the final sell price. So really what we're looking for here is how much is each share worth. Put that in black here. Each share is worth S dollars. That's what my variable is going to be. S is the number of dollars the share is worth. Now, if Al receives 5 shares, so Al receives 5 shares, Bob receives 3 shares, Cody receives A, B, C, and D. I'm sure that's by design. Cody receives 2 shares, and Dave receives 2 shares as well. If the business sells for $840,000, how much is each share worth? Well, all we're really doing here is adding up all of the shares that were given out and seeing how much of that becomes the $840,000. So really all we have to do is add up all of the shares. Cody's shares and Dave's shares. And all of this must equal $840,000. Well, we have a single variable here. We just need to combine them. We can solve for this equation. 5 plus 3 is 8, plus 2 is 10, plus 2 is 12. So combining like terms gives us 12s. And now all we have to do is divide by 12. So each share is worth, looks like $70,000. Okay, here's the last problem. Lori runs a small cafeteria. She must set aside $25 of her revenue, or 25% of her revenue, for taxes, and she has to spend $1,300 for expenses. How much total revenue, how much should she totally bring in if she wants to generate a profit of $20,000 per week? That means that she needs to end up with $20,000. What you can think of this as is if we take a total revenue amount, let's say R for revenue, and we take off the taxes and the expenses, then this thing should equal $2,000 left over, right? Because we're just taking off the expenses off of the revenue to get, the profit. So if we have a total revenue and then we take off 25% of that, that's the same thing as saying 0.25 times R, that's 25% of R. And we take off the $1,300 for expenses like food costs and utilities and things like that. Then what we want to have remaining to be at least $2,000. I hope that is clear of how I set that up. Really, we're just taking a dollar amount in and putting dollar amounts out, and so that it balances out to be $2,000 total. This is a linear equation with one variable, and we can solve for that. So we have 1r minus 0.25r is going to be 0.75r. Minus 1,300 equals 2,000. So we need to get rid of the non-variable term, the 1,300 first. That's what gives me 0.75r equals 3,300. And now I can solve for r by dividing out 0.75. This gives me $4,400. If she takes in a revenue of $4,400, then she will make as profit Profit is really just revenue minus costs. With the cost of 25% going to taxes and $1,300 going to expenses, then she'll make a profit of $2,000, and that's going to be per week. So it's pretty nice.